Now, please welcome to the stage, virtually, Vladimir Vysotskii.
Dear colleagues, it is very pleasant for me to be here at our very good and very famous conference. Many thanks to organizer for the invitation. I would like to present new results of our new investigation related to principally new method of realization of LENR phenomena. It is well known currently, it is believed that LENR can be implemented only as a result of a target impact on the active system and only during the immediately after the end of this impact. For example, in the process of electrolysis, with special diffusion, during cracking or screening, at laser action, and so on. We have shown for the first time that such a long quasi-continuous LENR process can proceed in usual stationary medium without any non-stationary external action and without any force impact. In particular, as a self-controlled and unlimited in time quasi-periodic process in stationary low-temperature magnetized plasma. This process contained two main periodical repeated phenomena. First one, LENR in a system of charged particle with a quick turning on of the magnetic field. One of the most effective methods for overcoming the Coulomb barrier is the implementation of nuclear fusion at low energy is the use of coherent correlated state of particle. Such states are characterized by both very large, in fact, giant and very long fluctuation of energy and momentum of this particle. The state corresponded to the modified Schrödinger-Robertson uncertainty relation. For example, one relation to pulse and coordinate, another one for energy and time, so on. What is different from the standard Heisenberg relation? The presence of the coefficient of correlation that may be changed in the interval from -1 up to +1. And in this case, you can see that a right part of this formula may be increasing to very big values. The simplest and most effective method for creating such states can be implemented in a non-stationary harmonic oscillator. The simple estimation of efficiency is the effect of correlated state. For example, let's consider correlated state. It is a state of superposition for particle is potential well. In this case, wave function is superposition of agent function of on each level with different coefficient and different phase. In the case of coincidence of the phase of the wave function, for example, such condition, we have the coherent superposition, coherent adding, and very great increasing of the fluctuation of energy. This leads to satisfaction of the such Schrödinger-Robertson uncertainty relation for coordinate pulse. From this value, it is easy to calculate the volume of the fluctuation of pulse, and using such value, it is easy to calculate the fluctuation of kinetic energy. But this standard formula, it's a typical formula for non-relativistic case. In this case, you can see fantastic increasing of the fluctuation of energy. Let's see some simple. If the size of potential hole is about several angstrom in non-correlated state, where it is coefficient correlated, G is the coefficient of efficiency of correlation. Is dependent very simple. G is 1 divided by square root 1 minus r power 2. For non-correlated states in such potential hole, for example, proton has a fluctuation energy on the level only 2 milli-electron volts, very small. For correlated states with typical parameters, fluctuation of energy may be from 2 up to 200 kilo-electron volt, fantastic value. The physical reason for increasing the probability of tunneling effect is related to the fact that formation of correlated state lead to cophasing in coherent submarine of fluctuation of the momentum. For example, in the coherent state, fluctuation of momentum is the sum of the partial fluctuation on all levels. It is easy to calculate the dispersion of this case. You have the dispersion has two numbers. It is traditional number. Dispersion is equal of averaged value of pulse. But if you have the second in red formula, it is increasing by a parameter or n, and it is a number of agent level, number of agent state, energy state of particle in such level. So the same increasing related to the increasing of kinetic energy. It is very simple schematic. In a correlated stack, fluctuation of pulse on each level of superposition state in non-cophasing, different fluctuation, different amplitude, different direction, different phase, so on. In correlated state, we have in some moment very great increasing by the process of cophasing and of course increasing fluctuation of both pulse and both kinetic energy. Very interesting question. How such state can be released for a particle in a magnetic field? The state of charged particle in a magnetic field corresponding to harmonic oscillator. Well, no. It is so named Landau quantization. It is the same wave function, the same spectrum of energy, and the same frequency, Landau quantization. One of the possible methods for coherent correlated states formation, the following. When the magnetic field is quickly turned on, the coherent superposition state is formed and very sharp increase in fluctuation takes place. For example, if we have the very sharp, quick increasing switch on, turn on of magnetic field, we have the generation of very large fluctuation. It is the amplitude of spectrum of changes dependent of the time of the coefficient of efficient correlation. You can see its parameter equal up to 1,000 and more. Okay. The generation of such giant fluctuation of momentum and kinetic energy is equivalent, very interesting, is equivalent to very sharp increase in effective local temperature for a given particle. It is averaged value of such parameters. If we have the temperature effective is usual temperature divided by and multiplied by coefficient of efficient correlation power 2. It's very great. It's increased by many times of magnitude. What is the duration of existence of the format JS? It is very easy to calculate. It is in the, for example, in a system like plasma, is duration equal to the duration of free pass of free pass between two collisions. According from theory of plasma, it equal to such formulas, yes. For example, if we have the coefficient of correlation of from 100 up to 1,000, and if the temperature of low temperature plasma is 10 electron volts, duration of correlation states, such correlated states, it is the average duration between two collisions, is equal, for example, from 1 millisecond up to 1 microsecond, for plasma with concentration about 10 power 16, 18 particle per centimeter cubed. Okay. Very interesting next ideas. At the first glance, it seems that in the case of an oscillator formed on the basis of the interaction of a charge, for example, proton, with a constant magnetic field, such an effect takes place only during a very short initial time interval. It is about 1 millisecond, no more, after the magnetized field is turned on and has no prospects in stationary system with a constant magnetic field. The possible solution is to use a system with very frequent turning on and off the magnetic field with very steep fronts, which is technology difficult to do and required a lot of energy. It is not interesting. But next step, it is next position. A more detailed analysis shown the situation changes dramatically if we take into account the features of real, not time-averaged microdynamics or multiple successive mutual transformation of atoms and ions that occur in stationary low-temperature hydrogen plasma. This is due to the very important circulation that in any stationary plasma, there is a continuous alternation of the process of ionization and recombination of atom ions, changing state, ion, atom, ion, neutral atom, ion, neutral atom. These processes are more significant in low temperature by Drusen plasma with a temperature close to ionization potential atom and exceeding the characteristic potential of dissociation of the hydrogen molecules into atoms, because it is very interesting take into attention not molecules by pure atom hydrogen. In such a plasma, red text, each active ionization of hydrogen atom corresponding to a pulsar switching on of the interaction of the format ion with the magnetic field as a formation of large term GZS. And next one, each act of recombination event corresponding to a pulsar switching off. First was switching on, next one switching off the interaction before the next ionization event. So we have such period of changing. Each successive cycle of ionization recombination process in low temperature plasma is characterized by 5 characteristic time intervals. First one, the duration of ionization process of the individual atom. So it is process of interaction, process of transformation of atom to ion, described by such value, very small value. Next one, duration of existence of a created coherent correlated state after its creation. We have discussed this problem. Next one, duration of state of hydrogen in ionization state before the start of recombination process, more long process. Next one, duration of the process of recombination of individual ion proton. This process approximately equal to process of ionization, very fast process. And next, last process, duration of state of hydrogen in the form of atom until the moment of next ionization. So start process ionization, finish next step of the ionization also. You can see the following scheme, such process schematically. It is a schematic dynamic of the alternating fluctuation of the effective temperature of atoms ions caused by the alternation of states of ionization recombination. For example, first state, it is an atom, neutral atom. First process of ionization, switching on, formation of ionized state. On the front of such state, we have the generation very great coherent state and generation of very great amplitude, the fluctuation of energy, very great temperature. And also we have more long time of ionization here, right? And next step is a transformation to the neutral atom or switching off of the process of hydrogen interaction. And next step is also ionization, formation, duration, formation of coherent correlated states, generation of very great and very long related to the atomic scale, fluctuation of energy, very long, about, according to our calculation, is about half of the period of state atom in the form of the ions. And next up, format 2 recombination. So we have ionization, recombination, ionization, recombination. We have very great frequency, switching off and switching on, process of interaction of atom with field, magnetic field. Not because we have changed magnetic field, but because we changed the state of atom. Because charge state, neutral atom, charge particle, neutral particle, so on. Based on these results, it is easy to calculate that the duration of coherent correlated states existence value significantly exceed the duration of the reverse model of existence of considered hydrogen form of the atom until the moment of ionization. In this case, the relative compared to all atoms and heavy ions fraction of nuclear from the plasma composition that ions at any time in a given system in coherent states, and whole state is characterized by anomalous large fluctuation as described by such formula. In this formula, it is P dissociation. It is a very close to 100%. It's a probability of dissociation of atom if the temperature is about or more typical temperature of ionization of hydrogen, not ionization, but dissociation, 4.5 eV. And also it is a relation of duration of existence of coherent correlated states to full period. So total duration of average duration of atom in state of ion and duration in state of molecule of neutral atom. It follows the above estimate that the quantity or such value, such probability, total probability, which depend on the plasma temperature density, is large and equal from 30 to 50%. So about half of the time we have the generation very large fluctuation of energy or effective temperature from typical temperature of low energy plasma about 10 electron volts up to several tens kilo electron volts. Okay, it is a strict calculation, the dynamic of LENR stimulated nuclear fusion based, for example, on such DD reaction is such the formula. It is a calculation of the dependence of nuclear interaction rate. It is well known in the theory of thermonuclear fusion. It is a product of cross-section of reaction by velocity averaged for DD reaction. It is a value is equal to 10 power about minus 16 centimeter cube per second. And also, if we have the usual uncorrelated state with coefficient of activation equal to 1 units, so nuclear rate is very small. It's small by about 50%. And any reaction is possible. In this case, for example, if we have the plasma, low temperature plasma with concentration about 10 power 60 centimeter cube, and at initial temperature about several electron volts, the rate of reaction, the velocity of reaction is about 10 power 16 per centimeter cube per second, very large velocity. Conclusion: efficient nuclear fusion in a low temperature plasma at its initial temperature from 5 to 30 electron volts can last an indefinitely long time and does not require additional energy after the start of the process. It is very interesting. Not necessary additional heating, additional screening, so on. Such a quasi-periodic, self-regulating, quasi-stationary nuclear fusion can exist only in relatively small temperature range, about from 10 up to 30 maybe electron volts. First one, as the temperature rises, the process of periodic recombination becomes unlikely. Another, at lower temperature, the process of periodic ionization becomes unlikely. Both body about several electron volts, several tens, it's an upper and lower interval of working regime. Another very important advantage of CCS-based reaction is the possibility of a very significant increase of the pulsate effective temperature, which can reach several tens, for example, from 30 up to 100 kilo electron volts. This makes it possible to implement those function reactions involving heavy isotopes that cannot be implemented with conventional thermonuclear fusion and by traditional nuclear fusion methods. Similar reaction, for example, generation of creation of iron-57 or barium-138, but in much lower fusion rates. Of course, we have observed in our experiments on transmutation of isotopes in biosystem. In such experiments, duration experiment was several weeks up to several months. But in such system, it is possible several seconds or several tenths of second. And also there is very additional, very interesting results. It should be noted that such a self-controlled model of LENR realization is a presence of magnetic field, and low temperature plasma gives a possible answer to the very old and famous question. Oh man, now this problem. Why it is necessary to apply the electric current to the heating solenoid in Rossi experiments if a lot of heat is released in this experiment? Of course, it's a standard question. The possible question is very simple. This heating solenoid is necessary not only for the initial starting heating and creating of hydrogen atmosphere in the volume of closed working chamber, but also for creating a magnetic field that affects the state of low temperature hydrogen plasma in the implementation of LENR closed chamber similar to the scenario considered above. So, traditional question, why in Rossi experiment additional very small heating? It is one of the possible simple. Heating, necessary not heating, but necessary electric current to the heating solenoid, because such solenoid created the magnetic field, and magnetic field can stimulate hydrogen plasma that existed in the volume of closed chamber. Okay, it's very interesting result of our calculation of the very well-known simple processes plasma processor ionization recombination, very often very high frequency, many maybe a frequency of such cycle about several kilohertz per second. In each act of ionization, the process of formation of coherent correlated states place. After you switch off such process, and next ionization will also creation such process. Okay, thank you for the attention. I finished.